The Big Bang Theory explained. The birth of everything, also known as the Big Bang. The belief that the universe was born unexpectedly and is not infinite. Until the middle of the 20th century, most scientists thought of the universe as limitless and ageless. Einstein's theory of relativity gave us a deeper understanding of gravity, and Edwin Hubble discovered that galaxies move away from each other in a way that matched previous predictions. Cosmic background radiation was detected by accident in 1964, a remnant of the early universe that, along with other observational facts, led to the development of the Big Bang Theory. Like the Hubble telescope, enhanced technology has given us a good picture of the universe's structure. Welcome to Brainbender Solarium. Join us as we travel through space and explore the Big Bang Theory. Many cosmologists assume we know the theory of the origin that began seconds after the Big Bang. This theory, which was painstakingly pieced together over 50 years while lacking in sufficient detail, represents the greatest intellectual accomplishment of the human, the crowning glory of our species. This theory was developed through an unprecedented synthesis of astronomy, particle physics, astrophysics, cosmology, chemistry, and other sciences. Recent findings suggest that the growth of the universe is accelerating. But what is the Big Bang? How can something come out of nothing? First of all, the Big Bang was not a blast. It was space stretching all over at once. The universe began very small and rapidly grew to the size of a football. The universe did not expand into anything. Space only expanded into itself. The universe cannot extend into anything because the universe has no border. There is, by definition, no outside. In a warm, dense climate, energy was embodied in particles that existed for only the smallest glimpses of time. From gluons, pairs of quarks were formed that damaged each other, perhaps after giving away more gluons. The quarks discovered other short-lived quarks to associate with, creating new quark pairs and gluons again. Matter and energy were not only hypothetically parallel, but it was so warm that they were essentially the same material. Matter triumphed over antimatter somewhere in this moment. We are now left with nearly all the matter and almost no antimatter at all. One way or another, 1 billion and 1 matter particles were created for every 1 billion pieces of antimatter. Instead of a vast ultimate force, there were now many advanced versions operating under different laws. The universe has now reached 1 billion kilometers in diameter, leading to a drop in temperature. The sequence of quarks that are born and transformed back to energy instantly ceases. Quarks begin making new particles, hadrons, protons, and neutrons. There are so many combinations of quarks that make all types of hadrons, but very few are stable for any length of time. The universe, which has expanded to 100 billion kilometers, is now cold enough to cause most neutrons to convert into protons and form hydrogen's primary atom. Imagine the universe at this stage as a boiling soup, 10 billion degrees Celsius, filled with innumerable particles full of energy. For the next few minutes, things get cool and settle down quickly. Atoms developed from hadrons and electrons, providing a stable and electrically neutral surrounding. Some call this time the Dark Ages, since there were no stars and hydrogen gas did not allow visible light to pass. But what does visible light mean when nothing is living to see it? As the hydrogen gas exploded after millions of years and gravity placed it under tremendous pressure, stars and galaxies started to form. Their radiation melted a solid hydrogen gas into a plasma that still permeates the universe and allows visible light to pass through. There was light, but what about the part we didn't discuss? What happened at the very beginning? This part is referred to as the Big Bang. We don't know what happened here. To understand what happened, we need a theory that unifies Einstein's relativity and quantum mechanics, something countless numbers of scientists are working on right now. This knowledge gap leaves us with a lot of unanswered questions. Was there another universe before our own? What started the Big Bang, or was it spontaneous, based on scientific laws we do not yet understand? We have no idea, and we may never know. We understand that the universe as we know it began here and subsequently gave birth to particles, stars, galaxies, the Earth, and humanity. Since we were made out of dead stars, we are not different from the universe, we are part of it. It's possible to think that we are the path through which the universe experiences itself. Although we can theorize how the world came to be, likely the Big Bang was not the first inflationary phase the universe has ever witnessed. Some scientists assume we live in a place that goes through daily cycles of inflation and deflation, and that we are only living in one of those periods. At the time of the Big Bang, all the energy in the universe focused on a tiny point smaller than the atom's nucleus. This theory encompasses not just the Big Bang. Modern cosmologists infer that matter, space, and time all started from a microscopic point and grew violently and indefinitely. Science will not rest until we can drive our theories back much further in time to the exact moment that the universe came into being. Thanks for joining us. We hope you found this video interesting. If so, take a look at some of our other videos you see on the screen now. Also, ring that bell to keep up with new content that we publish weekly. We'll see you next time here on Solarium.